reference angles. When I'm talking about a reference angle, this is the angle. We use theta r to represent our reference angle. Less than 90 degrees. So it's an acute angle. That is created by the terminal side of angle theta and the x-axis. I got it. Molly, you're fine. So of course, we're going to look at some examples because I know it's kind of hard to envision. So if I had a unit circle, because we're talking about this in the context, of a unit circle, and I, on this unit circle, was looking at the angle 315 degrees, which is this one right here. The acute angle that my terminal side makes with my x-axis is my reference angle. So that blue one here would be my reference angle, which we use theta r to denote. To find that reference angle, does anybody have an idea of how I could calculate it? 360 minus 315. If we did that math, we would figure out that this reference angle equals 45 degrees. It's pretty easy to figure out what it is. Oh yeah, sorry, Colin. Anybody have an issue of how we identified the reference angle and then found its angle measure? Sorry. No? For the most part, we're okay, right? It's pretty easy to identify. Let's go ahead and do another one just for fun. So this time, I'm going to have the angle 120 degrees. And I would like to identify the reference angle to that angle. Of course, I know that's the acute angle that is created between my angle and the x-axis, so it has to be this one right here. And then how do I find the measure of that reference angle? 180 minus 120. That's going to tell me that this reference angle measures what? 60 degrees. Anybody have any major issues with identifying your reference angle measure? So how we identify is actually a little bit different depending on which quadrant my angle lies in. So we're going to write the rule for all 4 quadrants. So for quadrant 1, if I have some angle created, of course, by my fixed side and my terminal side, my reference angle is also that angle because it's the acute angle created by my terminal side and the x-axis. Do we see how that happens on this one? Okay, so in quadrant 1, anytime I have an angle, the reference angle is going to be that same angle measure, which means that they're equal to each other. In quadrant 2, of course, that changes. So if I have some angle in quadrant 2, you guys already told me that to find my reference angle, I would just take 180 minus whatever angle I had. Of course, that's the degree rule for finding it, if I had a radian measure here, then I would change this to pi minus theta. So we have to remember that we're not always measuring in degrees. We could also be measuring in radians, which means that I need to think about 180 in pi as being equivalent, and then 360 and 2 pi also being equivalent. Again, we have a different rule when it comes to quadrant 3. So in quadrant 3, or if I had an angle that ended up in quadrant 3, to find my reference angle, which is going to be this one right here, I would do my angle minus 180 degrees, or theta minus pi, depending on if I was measuring in degrees or radians. Do we all see how these kind of fit, or how I came up with them, essentially? Of course, we have one more quadrant, and then we are finished with the kind of reference angle thing. We're just going to practice it a little bit after this. So those were quadrants 1 through 3. Let's go ahead and look at quadrant 4. So if I had an angle that ended up in quadrant 4, my reference angle would be this angle created by that angle in the x-axis. And then to find that reference angle, I would do 360 minus my angle theta, or we could rewrite that as 2 pi minus theta if I were measuring in radians. You guys were already able to figure out these reference angles without these formulas, but this, if you get stuck, is a good way to kind of think about it or try to reason your way through them, okay? So these are just in case you were to get stuck somewhere. Of course, we're going to practice it. I'm going to give you a couple angles, and you're going to find our reference angles. And then we're going to move on to the next topic, okay? You good, Colin? Yeah. Okay. So I'm going to give you an angle theta, and you're going to find the reference angle for that angle. So for the first one, let's assume that my theta is 5 pi over 6. So it might be helpful, for you to look on your unit circle and figure out what 5 pi over 6 is, or which quadrant it lies in, if you don't already know. Then I always suggest that we draw that angle, and I'm especially going to draw it because I don't have the unit circle in front of me. So if I were drawing this angle, I know that it's in which quadrant? 2. It is this one right here. Which means that my reference angle is going to be this little wedge right here, which measures what? Well, to find it, I have a rule that says I can take pi minus 5 pi over 6, right? I chose the pi because I'm measuring in radians here, not degrees. I know that pi with a denominator of 6 would be 6 pi over 6. When I subtract 5 pi over 6 from that, then I'm left with what? Just 1 pi over 6, right? Is that the reference angle that you already calculated on your own? Anybody confused by why this reference angle right here is pi over 6? Are we all okay with how we found that? Does that make sense? So the reference angle when we're talking about this quadrant is kind of just like what little piece is still needed to make this one full half of the circle. I knew I already had 5 portions. I needed one more. So pi over 6 was my reference angle on this one. Really, truly, does anybody not understand that? Or where I got it from? Okay, let's do another one. Let's say for this example that my angle is 280 degrees. So this one is not on your unit circle, which is why I chose it, but we can use our unit circle to draw approximately where it exists. So everybody look at your unit circle if you don't already know which quadrant it exists in, and then I'm going to call on somebody and you're going to tell me. Molly, which quadrant is 280 degrees in? Quadrant 4, because this is 270, so it's just a hair past that. That's way too far, but that's okay. And then if I couldn't already figure out what my reference angle is, I know that I could use that cool little equation that I found for quadrant 4 to find that reference angle. So that equation for quadrant 4 says I do what minus what to find my reference angle. 360 minus my angle. Why did you choose 360 and not 2 pi here, Colin? Because it's in degrees. Make sure you're recognizing that. So to find this reference angle, I'm going to do my whole circle minus the angle I'm already encompassing. And then when I do that subtraction, keep writing Q, I get what is my reference angle? 80. Oh my word. Okay. Oh, so happy. Any questions, concerns, or issues with finding reference angles given a specific angle on a unit circle like this? Or that exists on any circle, period? No? Okay, so we're done with, well, not done, but we're halfway done.
All right.
So this was reference angles. If you have any issues, of course, come talk to me. I do actually want to do one more example because I forgot I put it in the homework, just to make sure you kind of realize what I'm asking for. And then we're going to move on into inverses, which is pretty much all calculator, which is nice. So the last example I would like to do for this one, please, please, please write it down.
One day notes.
Yes. This time my angle theta is negative 2 pi over 3. We've done this before. So a negative angle, instead of starting here and going up, it starts here and it goes down. It still measures the same though. So I know that 2 pi over 3 is equal to how many degrees? Anybody?
135.
135 degrees. Is it actually 135 degrees?
I don't think so.
It's not. That's 3 pi over 4.
315.
120. So this is negative 120 degrees. That's kind of hard to imagine on a graph, but I know that I can find its positive coterminal angle, which will be a lot easier for me to identify. So how do I find its positive coterminal equivalent? Add 360 to it. And when I do, I get what measure? Positive 240. So I go to my unit circle. I find where positive 240 is. It's right here. But then I remember my angle was negative, so it opened this direction to get there. Okay, just so you remember what a negative angle looks like. My reference angle is still the same as it would be for a positive 240 degree angle, however. It's still going to be this portion right here. So how do I find that portion? Ismail? 240 minus 180. Yes. And that gives me what?
60.
So my reference angle right there is 60 degrees. Questions, concerns, or issues with that? Are we okay with that? So you're going to have positive angles and you're going to have negative angles. If it gives you a negative radian, I always encourage you to change that into degrees first because that's sometimes a lot easier to work with, okay? Questions, concerns, or issues on reference angles? Fantastic. Now we're going to do function inverses. And by functions, I mean trig functions. I will suggest that you go ahead and get out your unit circle right now, because that's going to be helpful. Okay, so once you get out your unit circles, I'm going to suggest you do it quickly, that way you have plenty of homework time. We're going to start writing what I mean by trig inverses. So we know that if I'm talking about sine of an angle, I have sine of some angle theta equals some number k, right? We know this. Trig inverses then goes the opposite direction. So if I don't know what the angle theta is, but I know what sine of that angle is equal to, I use an inverse to backwards solve for theta. We use the sine -1 and the cosine -1 and the tangent -1 that are on your calculator. Okay, so this is where those are going to come in handy. Also, if you don't have sine -1, cosine -1, or tangent -1, but you have arc cosine or arc sine or arc tangent, that is the same thing. Before we actually do any calculations, however, we're going to write what all of the inverses are so you know how to plug them into your calculator, and then we're just going to practice using them. So if sine of theta equals k, then if I needed to solve for theta, I would do sine inverse of what my sine equaled, which was k, and that's going to give me my angle. Whatever mode you're in is the type of angle it's going to give you. So if you're in degree mode, it's going to give you the degree angle. If you're in radian mode, it's going to give you the radian angle. Okay? We are mostly going to use radians here. I can't say all the time, but mostly. So then I know I also have cosine trig functions. So if cosine of theta is equal to k, and I need to solve for theta, then I would use cosine inverse of k to get theta. Same thing for tangent. If I had tangent of some angle equal to k, then tangent inverse of k would equal that angle. Everybody have these three written down, because the next three are a little bit different. As you're looking at your calculator right now, we don't have a cosecant inverse, or a secant inverse, or a cotangent inverse.
I don't even have my calculator.
You don't have any of them? What calculator are you using? Like, turn it up so I can see it. It should have it. I'll look at it in a second, but it should have them.
It should have like.
Yeah, it should be like right above your tangent,
I don't have
sine, cosine. I will look. It should have it on there.
They said it.
No, it should.
I had the inverse of those.
Yes, okay. So no calculator has cosecant inverse or secant inverse or
I don't even have
cotangent
cosecant
inverse.
there. Yeah.
Yeah, we don't have.
No calculators have any of those inverses or any of those trig functions. There's a reason for that. Sorry, I understand what you're saying now. I apologize. I thought you meant yours didn't have sine, cosine, or tangent on there, and I was really confused. So there's always a way around putting these directly into a calculator because, well, you don't have the buttons for it. But we do know that they are reciprocals of each other. So we use that knowledge to plug them into a calculator. So if I want cosecant, if I want to use cosecant inverse, what is the reciprocal to cosecant?
Sine or sine.
So I'm using sine inverse. But when I use sine inverse, I have to accommodate for the fact that I'm using a reciprocal. So I do sine inverse of 1 divided by k. So if cosecant of some angle is equal to k, then sine inverse of 1 over k is equal to my angle theta. Same thing kind of works if I have secant of theta equal to k. then I'm going to use cosine inverse of 1 over k, and that's going to give me my angle theta. Same thing for cotangent of theta equal to k. Can you guess which trig inverse we're going to use? Tangent. Oh my goodness, you guys are so smart. But it's tangent inverse of 1 over k. So these are the 6 trig inverses and how to plug them into your calculator. Again, remember that if you see arc sine, that is the same as sine inverse. Same for arc cosine or arc tangent. The arc is the same as inverse. Okay? Remember, those are equivalent because different calculators have it different ways. So what we're going to do is we're actually going to practice using these. And I only have like 6 examples and we're done.
Only 6?
Okay, my 6 examples took up that much space.
Okay, Carmen takes up more than space.
So the first one, this is one where we're going to use your unit circle. Okay, so we're going to start with the unit circle, then we're going to use the calculator. So if I know that sine of theta is equal to 1, I want to find theta. So this means that sine of some angle has to be equal to 1. So on my unit circle, I'm looking for a 1 in what coordinate spot? X or Y? What is sine? Y. So I'm looking for a 1 in the Y spot of some terminal point. There could be more than 1. There could only be 1. You never know. Do I have any angles that have a sine of 1?
90 degrees.
90 degrees. Again, I want radians. So theta here is equal to pi over 2 because sine of pi over 2 is equal to 1. So we just kind of looked at it backwards here. Let's do another one. Let's say that, tangent is equal to 1 here. It might be helpful here to use the chart on the back. Why? Well, it's all listed out, but what is tangent in terms of my coordinates? Y over X. So it's not just one of them, it's a mixture of the two of them put together. So it's really, really hard to imagine that for every single angle. But you already made a chart that has all of our tangent values in it, so why waste the time? So do I have any angles where tangent is equal to 1?
45, 25.
Again, I want radians. So what are the radian measures of those angles?
5 or 4.
And? Okay, so I had 2. I had pi over 4, and I had 5 pi over 4, right? Yeah. Without any more information, I don't know which angle I was actually looking at originally, so I have to include both of these because I don't know which one I was originally looking at. Are we okay with this so far?
Why is it 2?
Because I had 2 angles that gave me a tangent equal to positive 1.
Are we going to use this?
Majority of quizzes and tests, yes. The one on Tuesday, yes.
Yeah.
Not all, but majority. Okay, so let's do another one. This one is all yours. I would like which angle or angles for which cosine of theta is equal to 1/2.
You just want them written like theta equals that and that.
Ray, what'd you come up with? Nothing? Oh, you don't have a unit circle. I'm sorry, I took that. I will give it back at the end of this class. I'll just take pictures so I can grade from there. Mallory, what you got? Awesome. That's also what I had. Are we all okay with that? Anybody have any major questions, concerns, or issues with finding this using the information from our unit circle and unit circle chart? Yes.
Do we have to plug it into like the actual like equation part of it, or do we just leave that as two?
I'm a little bit confused about what you're saying, I guess. So like the equations that we just wrote down?
What we did for the first one when we like the sine and then put like the radian on the two side of it.
Oh, no, I was just showing you how it works. So like, because we found the angles, that means the trig function of that angle equals the desired value. I was just showing you how it fit together. Yes,
Do we have to put theta equals for each one? Or
Yes.
Okay.
I expect theta equals for each angle because there's a reason for this. So what we were doing was we were just finding the angles between 0 and 2 pi, which satisfied my conditions. But those are not the only angles that exist out there, right? Because I have an infinite number of coterminal angles. So if I asked you to find all, that's the key word here, angles where theta equals, or where, we'll just use the same example. So if I asked you to find all angles where cosine of theta equals 1/2, we're not just limiting ourselves to these two answers. We're limiting ourselves to these two answers and all of their other coterminal angles. So the way we would write this is we would say theta equals pi over 3, and then we would put plus and minus every circular multiple of that. So plus and minus 2 pi n. So every multiple of 2 pi, which means every other rotation of the circle as well. And we would do the same thing for 5 pi over 3. We have to have that plus or minus 2 pi n if I ask for all angles, not just the angles on the unit circle. Okay, because we know that these have an infinite number of coterminal angles that also line up with it, which means it would also give me the desired cosine value. So if I say all, I want plus or minus 2 pi n. Are we all okay with that? The key here, or the difference here, is that we use plus or minus 2 pi n for sine and cosine, but we use plus or minus pi n for tangent, because tangent has a different period. We're going to learn about that next class, but I thought I'd go ahead and tell you now so you don't write it incorrectly. Okay? So plus or minus 2 pi n for sine and cosine, and equivalently cosecant and secant. And then tangent is plus or minus pi n, also works for cotangent. So now let's try one where we just plug it into our calculator, because I think that's a really good thing to practice. And I think we only need one because it's just putting it into a calculator. So first things first, I'm going to ask that your calculator be in radian mode right now. Are we all in radian mode? Okay, I would like to find the angle or angles where tangent of theta is equal to 0. And I would like for you to use your calculator. So that means we're using which button on our calculator? Tan inverse, so tan -1. And we're plugging in the 0, and then I'm getting an angle out of it. What do we get? 0. So this works for an angle equal to 0. There's a limitation to using your calculator. 0 is not the only angle where tangent's equal to 0. What's the other one?
Plus or minus pi.
No, on the unit circle, what other angles also equal? Okay, that doesn't count. What's another angle?
180.
180. So pi would also be an answer for this. So there is a limitation. When you use your calculator, it only gives you one angle, but we can easily look at our unit circle to find the other one. Okay? If I'm only asking for one, then 0 would have worked perfectly. If I was asking for all, or all of them between 0 and 2 pi, I want both of these answers. Okay? Any questions, concerns, or issues with this? No, we're good. On your homework, if I ask you to find an angle, like use inverse to find the angle, I'm just looking for the one the calculator gives you. Okay, because this is just a practice that you can plug it into your calculator. That's all I care about for those questions on the homework today. Okay? Okay, your homework is on Canvas. Go ahead and get started. It is 7 questions. Some of them are multiple parts, but not too long.